Campi Flegrei is not a volcano. It is a landscape that has never stood still. For centuries, the ground here has risen and fallen, not in a single disaster, not in a violent eruption, but slowly. Gradually, Roman observers recorded this phenomenon more than 2,000 years ago. Stone column, scarred by marine shells, now sit far above the present sea level. Ancient harbors once sank beneath the water, only to rise again. They did not call it a catastrophe. They understood it as a change in the ground itself. Today, science has a name for this phenomenon: bradycism, a slow movement of the Earth's crust, where pressure accumulating below causes entire regions to rise or sink over years. Campi Flegrei is one of the very few places on Earth where this process is continuous, measurable, and unmistakable. Not on a remote mountainside, but directly beneath densely populated neighborhoods. Hundreds of thousands of people live on land that is, by nature, unstable. By the mid-20th century, modern instruments began confirming what humans had observed for generations. The ground at Campi Flegrei could rise by tens of centimeters in just a few years. At times, the uplift was strong enough to crack buildings, deform roads, and force tens of thousands of residents to evacuate central districts. And then it would slow. No eruption, no lava, just a change in the shape of the land. That is what makes Campi Flegrei different. It does not behave like a sudden disaster. It behaves like a living system. And for decades, humans could do only one thing: observe it from the outside, until technology allowed us to move closer, not just measuring from the surface, but going beneath it. In 2000, for the first time, humans chose to do exactly that. They did not drill to extract resources. They were not searching for fuel. They were not generating energy. They drilled to understand what was happening beneath this land that never stays still. And here, the first question emerged: not, how dangerous is Campi Flegrei? But, when a geological system is not yet fully understood, does moving deeper into it remain observation, or does it become intervention? The movement at Campi Flegrei did not begin in 2012. It had already started years earlier. Around 2005, instruments began recording a slow but persistent uplift, not centimeters in total, but centimeters every year. To an untrained eye, the change was invisible, but satellites saw it. Radar measurements detected the ground rising millimeter by millimeter across an entire caldera. And this was not an isolated signal. Seismic sensor began detecting a growing number of small earthquakes, not large enough to cause immediate destruction, but too frequent to ignore. Scientists recognized the pattern. Campi Flegrei was entering another phase of unrest. This had happened before. Between 1950 and 1952, the ground rose sharply. Then again, between 1969 and 1972, and most dramatically, between 1982 and 1984. During that period, the center of Pozzuoli rose by more than a meter. Buildings cracked, roads warped, tens of thousands of residents were evacuated. And yet, there was no eruption, no lava, no ash cloud, just a landscape changing shape. That paradox is what defines Campi Flegrei. Powerful deformation without a clear outcome. For volcanologists, this posed a problem. Surface measurement could show what was happening, but not why. Was magma moving upward, or was the pressure coming from superheated fluids trapped deep underground, or from a complex interaction between both? The difference matters, because magma migration and fluid pressurization imply very different risks. By the early 2000s, scientists realized they were reaching the limits of observation. They could track deformation, measure gas emissions, count earthquakes, but the processes driving them remained hidden. And so, a question emerged within the scientific community. If the surface was no longer enough, Was it time to look below it? This was not a sudden decision. It followed decades of debate. Drilling into an active caldera carries risks: pressure, temperature, unpredictable pathways for fluids and gas. But without direct samples, models would remain incomplete. Predictions would remain uncertain. And uncertainty in a densely populated region is its own kind of danger. By the end of the decade, the decision was made. A scientific drilling project would be carried out at Campi Flegrei, not to exploit, not to extract, but to understand what was happening beneath a landscape that had already begun to rise. The drilling itself would begin in 2012, but by then, the ground was already moving, and whatever lay beneath Campi Flegrei was already active. The decision to drill at Campi Flegrei was not made lightly. For decades, the idea had remained controversial. Drilling into an active caldera is fundamentally different from drilling into stable ground. Temperatures rise faster. Pressures are harder to predict, and fluids and gases can move along pathways no model can fully anticipate. A mistake, even a small one, could alter the system being studied. That risk was understood from the beginning, which is why the project did not begin with a deep borehole. It began with a test. In 2012, scientists initiated a pilot drilling program at Campi Flegrei. The goal was not to reach magma, not to access extreme temperatures, and not to trigger any form of energy release. The objective was far more limited: to drill deep enough to directly sample the rocks, fluids, and conditions beneath the surface. The borehole would extend to roughly 500 meters, deep enough to cross key geological layers, but shallow enough to avoid known magma reservoirs. Every step was planned. Pressure control systems were installed. Temperatures were monitored continuously. The drilling rate was kept deliberately slow. This was not an industrial operation. It was a scientific one. And yet, the location itself made the project unprecedented. Campi Flegrei is not an isolated research site. It sits beneath one of the most densely populated regions in southern Europe. Any intervention, however cautious, carried consequences beyond the drill site itself. That reality shaped every decision. The project was reviewed, debated, and approved under strict monitoring conditions. The drilling began slowly, carefully. Data was collected in real time. Rock samples revealed layers shaped by past eruptions, hydrothermal alteration, and long-term fluid circulation. Sensors recorded temperature gradients, pressure changes, and chemical signatures. For the first time, scientists were not inferring processes from surface signals alone. They were touching the system directly. But even as the drilling proceeded, one question remained unresolved. Was the borehole simply observing what was already happening? Or had the act of drilling itself become part of the system? This was not a question that could be answered immediately. The drilling did not cause a sudden eruption. It did not trigger a catastrophic event to it, but it did coincide with a landscape that continued to rise. And that coincidence demanded caution, because in complex geological systems, change does not always happen at once. Sometimes, the effects of intervention are delayed. Sometimes, they are subtle. And sometimes, they are indistinguishable from the processes already underway. At Campi Flegrei, the drilling was completed without incident. The borehole was secured. Monitoring continued, but the ground did not stop moving. And with that, the focus of the investigation shifted, not to what the drilling had caused, but to what was happening after humans had crossed the boundary between observation and direct access. The drilling did not trigger a disaster, and that was exactly the problem. There was no eruption, no collapse, no single moment. That explained everything. The ground continued to rise, slowly, unevenly, just as it had before. Scientifically, this meant caution, but socially, it meant something else. Because when nothing dramatic happens, uncertainty has room to grow. After drilling, scientists had more data than ever. Better measurements, denser monitoring networks, direct samples from below the surface. But outside the research teams, certainty did not increase. It weakened. For residents living above the caldera, the distinction between natural unrest and human intervention became blurred. The drilling itself entered public perception, not as a proven cause, but as a point of proximity, a reminder that science was no longer watching from a distance. It was standing inside the system. This created a new tension, not between data and theory, but between explanation and responsibility. Scientists could say, truthfully, that the uplift had started years earlier. They could say, with equal honesty, that no causal link had been proven. But those answers did not fully address the unease, because risk is not only measured in probabilities, it is measured in trust. And trust becomes fragile when systems are complex and outcomes remain uncertain. In Campi Flegrei, science had crossed an invisible line, not by causing change, but by becoming part of how that change was understood. From that point on, the question was no longer what the ground was doing. It was what humans would do with incomplete knowledge and irreversible access. Because once observation turns into proximity, returning to a safe distance is no longer possible. Once the drilling ended, the responsibility did not. If anything, it grew. Campi Flegrei did not become a site of crisis overnight. It became something more difficult to manage, a place where scientific uncertainty met political responsibility. Authorities did not declare an emergency. There was no evacuation order, no statement that an eruption was imminent, but the situation was no longer treated as routine. Monitoring levels were adjusted. Seismic networks were reinforced. Satellite measurements were analyzed more frequently. Gas emissions were tracked in greater detail. This was not a reaction to a single event. It was a response to a trend. And trends are harder to explain to the public because they do not come with a clear beginning or a clear end. Risk assessments were updated, not to predict a precise outcome, but to define scenarios, best case, worst case, and the wide uncertainty in between. Civil protection agencies began refining evacuation models, not because evacuation was expected, but because not having a plan was no longer acceptable. This is how risk governance works in complex systems. You do not act because disaster is certain. You act because uncertainty is persistent. Communication became part of the response. Public briefings were held. Statements were carefully worded. Officials avoided absolute language. No guarantees, no deadlines, no promises that could not be kept. The message was restrained. Campi Flegrei was active, but activity did not mean escalation, and escalation did not mean eruption. Still, restraint had a cost. For residents, the absence of clear answers created space for speculation. Some asked why scientists were still drilling. Others asked why they ever had. Trust became a variable, as important as pressure or temperature. And trust, unlike geological data, cannot be calibrated. This exposed a deeper problem. Scientific systems are built to manage data. Governments are built to manage decisions. But Campi Flegrei required both, simultaneously. And neither system is designed to function without clear thresholds. In volcanology, those thresholds are rarely fixed. Signals fluctuate, patterns overlap, and warning signs do not follow schedules. At Campi Flegrei, officials were forced to govern without closure, to prepare without declaring, to reassure without certainty. This is where the limits of control became visible, not because the science had failed, but because science could not deliver the kind of answers governance prefers. No definitive safe, no definitive danger. only probabilities, confidence intervals, and ongoing observation. Over time, Campi Flegrei became more than a geological site. It became a case study in how societies live with unresolved risk, how decisions are made when waiting is also a choice, and how intervention, even when cautious, reshapes responsibility. The drilling had not caused a disaster, but it had changed the terms of engagement. From that point forward, doing nothing was no longer neutral. Every measurement, every update, every public statement carried weight. At Campi Flegrei, the challenge was never to control the volcano. It was to manage what could not be fully known and to decide how far humans should go in the name of understanding when the cost of that understanding could not be undone. Because some boundaries, once crossed, do not announce themselves. They only become visible when turning back is no longer possible.